Hello, everyone, and welcome to this week's AWS OnAir Data Dive, where our topic is introducing Valkey for Amazon ElastiCache and Amazon MemoryDB. And if you know what ElastiCache and MemoryDB are, you're going to love this show to learn more about the Valkey option for them. And if you don't know what they are, stick around because we're going to get into that and explain exactly what they are. I'm here with someone who knows pretty much everything about this entire domain, Kevin McGee. Kevin, what's your role here at AWS?
Hi, Jason. Thanks for having me. My name's Kevin. I'm a principal engineer here at AWS for the in-memory databases team, which is composed of both ElastiCache and MemoryDB.
So you've had a lot to do in this launch. It was Tuesday that we launched some big news, right?
Yeah, just a couple days ago. Yeah, Tuesday, we launched this new engine in both services.
All right, can you give me the 1-minute summary of what came on Tuesday?
Yeah, so both ElastiCache and MemoryDB launched a new Valkey option for the services. So you can go in and use this new engine to run both services.
All right, so if I'm using ElastiCache or MemoryDB, I have a new choice that I can make to switch from Redis OSS, the old one, now to Valkey, the new one. And is there any motivation for me to do this?
Yes. Not only is it a drop-in replacement for your existing Redis OSS cluster, but there is lower prices across the board for the different configurations on ElastiCache and MemoryDB. So there's added incentive to make the switch or to create new resources using Valkey.
How much are we talking?
Up to 33%. It's different for the different SKUs, but as much as a third reduced price.
Yeah, I've seen a lot of news right now where people are reacting very favorably to it. How do you get good press? Step one, drop your price by up to 33%, and people will love you for it. All right, so let's start at the beginning to make sure that people understand what all of these services are. So let's start with, I think, ElastiCache. We should. So what is ElastiCache?
Yeah, so ElastiCache is AWS's managed caching offering. And so instead of having to run a cache yourself and deal with, node provisioning and upgrades, management, security patching, ElastiCache takes care of that all for you. So if you're familiar with RDS as like the relational database service, ElastiCache does that for caching engines. So that's the high level for ElastiCache.
What's the classic use case for ElastiCache?
So ElastiCache is so classically the most common one is using it as a cache in front of another database service. So you can use it in front of something like RDS and store information there, so you don't have to hit the backend database every time you need to fetch information that doesn't update that frequently. But it also is used for sort of beyond caching use cases. So the cool thing about Redis OSS and Valkey is that it provides additional data structures that you can use. So rather than just flat key value pairs, you can represent things like leaderboards as an example, and be able to store data that you can access in a sort of a better, faster fashion than you would be able to in a backend database.
Yeah, I come from DynamoDB, right? You see the job title there. I'm a solution architect with DynamoDB. And hosting this show is my side hustle. But we think in terms of key value. We think in terms of maybe a partition key and a sort key as an index. But ElastiCache has really a lot of different data structures, right? I mean, leaderboard's one, because leaderboard is like, all right, I've got a bunch of people, someone who's got the highest heart rate, which horse is ahead in the horse race, something like that, which is not a direct key value, but it's even more than that, right?
Yeah, so leaderboard is one example, which uses effectively something called a sorted set data structure behind the scenes. So it maintains sorted order. You can do efficient queries of the different, top N or bottom N people in the set. But it has beyond that. So like you can use a hash data structure for something like a session store. As users log into your application, you want to store something temporarily for that user. There's data structures like geo capabilities where you can query within a given radius of a latitude longitude, something for like ride sharing queries. And then there's a bunch of different statistical data structures, something like a hyperlog log to estimate the number of views of a given ad. So it's used for real-time applications sort of across a variety of different use cases.
Gotcha. Memory-driven, low latency is kind of the deal, right? All right. Do you have a demo of this? Can we see it? How are you going to demo a cache? Kevin. What are you
Yes,
going to do?
I can. We can switch to the demo here. So I have a simple Python script here, well, relatively simple. And what it's using is a Redis cluster. So I'm running against a serverless Redis cluster here in US East 1. And what it's doing is doing the leaderboard. So we talked about the different scenarios for leaderboard. You could think of something like a Peloton or other interactive class. Here we have 100 people, which are with fake names, that are slowly moving ahead in their class, moving one at a time.
It's like the Olympics. They're rowing or whatever is their distance.
Yeah, exactly. They're trying to compete with each other, and we're seeing who is in the lead in terms of the overall class. So I have a loop here that's just running indefinitely. One in every 10 commands updates the leaderboard. So we'll increment this given key called leaderboard, and a random player moves ahead 1 space, 1 mile, 1 meter. And then the rest of them are the rest of the queries. The other 9 out of 10 are just actually querying the leaderboard. And so it's using this rev range command. So I'll run it, and we can see what outputs.
Yeah, reverse range by score.
Yeah, so Z rev range by reverse range. Reverse being that it's going from the highest to the lowest. So we want to see who's in first place here, not who's in last place. We don't want to make them feel bad. And we'll get the scores, and we're just doing the top 3. So every second it's going to output this race starting from 0. It clears each time I run it. So let's see here. So we got every second it's printing the status from the past second here. We have the number of requests made by a single client, latency, and then who's in first place and their scores.
How should I interpret the latency of 936 funny shaped US?
Yeah, so in the in-memory world, we talk in terms of microseconds often, rather than milliseconds, like you might in DynamoDB world. So this is actually the mu. It's 900 microseconds here. So with serverless, we're doing reads that where the average latency here is less than a single millisecond.
All right, so 980 microseconds is point something milliseconds.
Yeah, so it would be 0.9 milliseconds here per request on average.
I like the confidence to just do all your units in microseconds. That's how you know you're memory driven, right?
Yeah, and that's one of the primary benefits of using an in-memory database is you're able to get super low latency. And as a result, even though I'm just using a single connection to the backend, I'm able to do over 1,000 requests per second. But the actual database itself can do, or cache can do far greater than that. This is just on a single TCP connection.
This is a single threaded connection too, right? Because you're doing, yes. I mean, you can see that the lower the latency, the higher the end, because you're just as fast as one. This is a single-threaded client doing 1,000.
Single-threaded, yeah, no batching involved. The engine supports batching, but we're just doing one at a time in a loop here in Python too. So it's pretty impressive. We're able to see such low latency.
That's interesting. Yeah. Do you want to theorize what kind of throughput I could do? How many competitors could I have for something like this? Or
yeah, so right now we're doing 100 competitors on one thread. But in a typical scenario, you could do, a lot more threads across, a distributed application that are all querying and updating concurrently. We support up to 65,000 connections per object here in our serverless option. But the vast majority of use cases use, a couple hundred or a couple thousand connections, depending on the architecture.
Well, So you could definitely you could drive the Peloton leaderboard for a wide variety of people joining a class of who's got the highest heart rate or the most distance achieved or whatever.
Yes, yeah, that's and that's one of the typical scenarios for using ElastiCache.
All right, let's keep that running, because I know we're going to show a little bit later how do we upgrade from this backend, which is the Redis OSS backend, to a Valkey backend. We're going to see if we can do that without making that average latency go up, right?
Yep, that's the goal.
That's the goal. All right, so give me a quick summary then of MemoryDB as contrasted with ElastiCache.
Yeah, so MemoryDB is another service in the in-memory portfolio within AWS, and it previously offered a Redis OSS compatible API. As of Tuesday, it now supports this new Valkey option. And it has the same API interface as ElastiCache, so we could, access the same APIs, the Z anchor by, Z rev range by score. But the difference is that it is intended to be used as a database. So rather than a cache, which is sort of ephemeral data, we talked about Peloton, that data is stored solely in memory. And is not backed up to disk anywhere, so it's not stored durably. So there's a chance that the data can get lost. For example, even though you can have high availability in ElastiCache and have replication across multiple availability zones, there's still something called asynchronous replication, which means that only one node acknowledges that data in memory before it confirms to the client. So theoretically, in this example, let's say the node that we're talking to here that's storing the data goes away. We might lose some of these updates. Michael Reese might drop from first place to second place because we lost its one update here. And for a lot of scenarios, that might be okay. Something like a Peloton class that you might be able to update it later on. But for more durable use cases, you might want something like a database. And so MemoryDB provides the ability to have that data stored in memory and be able to access it in memory with this sub millisecond latency. But every write is stored durably across multiple availability zones before acknowledging. So it gives you that strong durability and strong consistency that you would expect from a database product, but really fast read queries.
Right. So the one that has cache in the name is the one that is ephemeral.
Correct.
Very durable, but not the promises you get of a database. And MemoryDB with a database in the name is the one that says, I have a durability promise. I will not acknowledge the write until it has been replicated from the node you wrote to at least one other availability zone. Is that how?
Yeah, minimum of 2 availability zones. And it's also then on disk. So you can do things like have single node configurations. You have no replicas. Okay, well, it might not be super available because if that one node dies, okay, we have to bring it up from scratch, but it'll remain durable because we can restore everything from a durable storage medium.
Right, but otherwise they have the same familiar API. They both would have a leaderboard. They both would have the hashes, the hyperlog log, the string get and set, and other data structures. But one is aiming for low latency reads and writes. I'm thinking ElastiCache. I'm thinking it through. You tell me if I'm right. ElastiCache, It's in memory. You acknowledge a write when it's written to a node. It'll propagate quickly, but I'm acknowledged because you wrote it to one node. That is, get in and out, right? Fast. Whereas MemoryDB, the writes have to be higher latency. Probably not a lot, but a little bit.
Correct. Yeah. So we talked about reads being in memory because the data is still stored in this engine in memory, but because the writes have to go to disk, we're talking about single-digit millisecond in terms of write latency because it has to traverse across availability zones, which can take a millisecond. There's speed of light concerns as well as being able to sync to disk, and so single-digit millisecond writes, but sub-millisecond reads.
Right. So I can keep the same performance on the reads when I want to, let's say I'm doing ad tech and I want to pull exactly out. I get the same speed because it's still in memory coming back to me. But when I do a write, it says, you asked for this to be really durable. Therefore, I'm going to copy it to another availability zone. So should this availability zone have any issue, we still are guaranteed that durability. And so therefore I have to wait them generally a millisecond or whatever to cross AZs, right? All right.
Correct.
Any other differences between ElastiCache and MemoryDB I should be aware of?
So another advantage to MemoryDB at this point is that we have a vector search capability that we launched earlier this year for MemoryDB. And so when you're building a Gen AI application, you can use MemoryDB for basically the lowest latency, sort of at highest recall rate offering that AWS provides for vector search. So powering things like retrieval augmented generation for Gen AI is something that you can use MemoryDB for.
Yeah, I knew the answer to that question because last week's show was how the NFL used MemoryDB to power a semantic caching use case where they would store and use that vector index to pull out previous generated runs. So like these were good answers and then fed that into an LLM as starter material. So it's recorded if people want to go back and see exactly a great use case of MemoryDB doing that. But that's not ElastiCache. That's MemoryDB only. It's a database.
Correct. Yes.
That makes sense. All right. So now we've got what ElastiCache is, what MemoryDB is. Redis OSS. We're hearing this. What should we know about Redis OSS?
Yeah, so Redis has been historically one of the most popular key value databases, or quote unquote databases, data stores in existence. It started back in 2009 with a developer named Salvatore Sanfilippo, who built this as sort of a side project, was interested in creating something and named it Redis because of its capabilities, basically being a remote dictionary server is what Redis stands for. The idea being you can just have
remote dictionary server, like define a define a word. No,
yeah,
not that kind of dictionary, Chase. That like
no, yeah, the dictionary like dictionary. Okay, everything's addressable by a key name. So okay, that's how you entry point into the quote unquote dictionary is you give it a key, just like any key value store you would have that key as the index, but it morphed into something sort of like a data structure server. So not only do you have a key, the value type isn't just like a flat string or a binary blob. You can actually represent these more complex data types as that value. And so that's where it grew. More and more data types were added over time, and that's continuing to grow today. So that was sort of a history of Redis. ElastiCache added the Redis engine to its portfolio back in 2013, and the response has been pretty tremendous. So we have had a pretty good experience running and operating at scale this Redis OSS engine.
Right. As I remember, you can do Redis or Memcached as kind of the two main options in ElastiCache. Does MemoryDB do both, or does MemoryDB just do Redis?
MemoryDB just supports Redis. So we've seen over time, Memcached predates Redis and is used more as a typical what you think of as a cache. It does more flat key value pair matching, and so it's a good option for customers who do want to just do like a cache in front of a database. But we found a lot of our customers, at least, were more interested in doing and using Redis and leveraging its additional capabilities.
Right. So I'd never heard the name before. It's a fun way to think of it, that it's a remote data structure that a bunch of different clients can go to this in-memory data structure that's on that machine over there remotely. And I can keep a leaderboard. You keep a leaderboard. We share the same leaderboard. I mean, that must have been a fun project for him to build up. And now it's become so widely used, right? That this API has become the API that a lot of people have used.
Yeah, and it's grown and grown. I think the simplicity of the API, as well as its power, has and ease of getting started, is what attracted a large number of developers to leveraging it.
Makes sense. All right, Valkey. Now we're ready for the thing that we've set the stage. We're introducing Valkey. So what is Valkey, Kevin?
Yeah, so Valkey is an open source project that was formed earlier this year in March. And it was created as a fork of Redis open source. So Redis Inc. announced that the open source project was changing license back in March and would no longer be BSD license going forward. So as a result of that announcement, the number of previous maintainers from Redis OSS and the community launched this fork of Redis OSS called Valkey, which was formed under the Linux Foundation, and its intention is to be the open source evolution of Redis OS, that was formerly Redis OSS.
What does the OSS stand for? Isn't that Operation of Special Services from World War II?
No, open source software is OSS. So this is referred to the licensing of how you can use it, and the Valkey retains the existing license of Redis, so that this BSD license is carried over and is now being shepherded by the Linux Foundation.
Okay, so Valkey's BSD license, that's the Berkeley license that we're familiar with, a long-standing open source license that allows people to do quite a lot with it.
Correct.
And so that's what Valkey's licensed under still? Under the Linux Foundation.
Correct.
With, is it getting traction? What are we seeing in Valkey?
Yeah, so as part of that announcement, we have over 40 corporate sponsors that have pledged to support Valkey, including AWS. Which is part of the reason why we had that launch announcement a couple days ago. It's gotten good traction from users too. There's already been over 500,000 downloads of Valkey just in under a year, and over 1,000 different contributions and 100 unique contributors to Valkey alone. So it's already minted this first release of Valkey 7.2, which is API equivalent to Redis open source 7.2 version. And so is a sort of a drop-in replacement, not a whole lot of additional capabilities, but the project's been moving on and already has just recently released an 8.0 release and is preparing for future releases with even more innovation.
Oh, cool. So a lot of the people who contributed to the Redis when it was open source, the Redis OSS when it was open source, want to maintain the open source lineage, want that shared community of aspect. I mean, I'm an old Apache member and things. I'm familiar with the advantages of open source. They wanted to keep doing the open source thing. So now they've named it Valkey. Valkey, key val.
Yeah, you don't get it off immediately, but yeah, it's key val, Valkey. It was reversed, and so it's a little clever play on words there.
Yeah, I guess key val was taken.
Less imaginative.
All right, so that set of people from industry and then probably individual contributors and what I was saying, we want to keep doing an open source version of this, and so that's what we're doing now with ElastiCache and MemoryDB. Stick with the open source, because that way a person is going to be able to say, well, maybe I want ElastiCache, but maybe I also want to do an open source. Right? It's not a vendor lock-in now if you're using ElastiCache and MemoryDB, right? Because it's open source right there. If you want the open source one, use it. If you want the AWS provided managed one, use it. But being able to jump back and forth, or any other service that wants to build on the open source can do so, right?
Yep. Yeah. There's interoperability, so you can export your data from ElastiCache, use it on your own EC2 instance or on your laptop, and be able to then import it. So it's the same engine and compatibility version across all of those different offerings.
Gotcha. All right. I'm going to want to go back to the demo, but first I should say we're going to do a survey, and I hope people are having fun, and you can fill out the survey. And this week, the first 500 people who do the survey can get $20 of AWS credits. I forget what it was last week, but it was nowhere near 500 people. So I think we didn't want people to fill out a survey and not be one of the first X many. So we're now doing this. Would managing the survey be a good use case of ElastiCache or MemoryDB, Kevin?
It depends on whether once a person fills out the survey, you want to ensure that they get their credit. I think that would probably be a better use case for MemoryDB. Because
500 people fill out surveys, and then you go, oh, where to go? I mean, it's ephemeral or durable source. I'm doing the the survey plug before we do a demo because you never know how a live demo is going to go. Maybe the demo's going to explode. Let's get those surveys locked in right now before we do this. By the way, if people have questions, because we've covered a lot of material now on what these services are and Redis OSS versus Valkey and whatnot. So you can ask questions and we can answer them. This is a live show. But if you've been leaving that demo running, Kevin, let's go back to it, because I understand that now I can do an upgrade to, is it still running? Yeah, all right, good.
Yep.
I can do an upgrade on my existing ElastiCache or MemoryDB in place. Is that right?
Yeah, that's right. And I was going to demonstrate that today. So it's been continuing to run, still seeing the same TPS and latency. So let's go ahead and do the upgrade.
Actually gotten faster. You're at like 9.
And it varies over time too. But yes, it's around the same. Microseconds, it can vary based on network congestion. There's a lot of factors at that low of a latency that can impact it, even plus or minus a couple 10%.
Sure.
So if we look up at the host name, we're looking for a cluster called Test Redis Serverless. So let's go over to the management console here. As you can see in the ElastiCache console, we have a new banner up here that talks about using Valkey.
Yeah, introducing Valkey, an open source project that is a drop-in replacement of Redis OSS, now available on ElastiCache with up to 33% lower price than other engines. All right.
Yep. So let's take the Test Redis Serverless one. Hopefully my font is readable.
All right.
Yeah. So click on that, go to Modify. You see it's running Redis version 7 here. So we'll just switch this to Valkey. It retains.
That was it.
Yeah, that was it. Have to apply the change.
Okay.
And it'll show you that you're currently running Redis. We'll switch it to Valkey. We'll hit Save Changes. And so now it's going to be processing this behind the scenes. It's saying that it's modifying. And eventually it'll show up on the Valkey page. So what it's doing behind the scenes, if we switch back to the demo, is that you could actually do this as an online operation. So unlike some databases where it requires offline maintenance to do things like version upgrades or something like an engine switch, this is done completely online. It'll continue serving requests during the time period and can be done sort of safely on a production workload.
Are we going to see when it happens? Are we going to see that microseconds jump or anything?
We shouldn't. So the idea is that what's happening behind the scenes is that it's upgrading the nodes one by one, but it's doing an N+1 replacement. So it's adding new nodes before it removes the old ones. And so you shouldn't lose capacity in terms of the ability to process commands while this is happening in place. And because it's API compatible and the engines are able to sync with each other, then it should be an uninterrupted upgrade process. There might be an increase in tail latency because as part of this, we do have sort of switchover that happens, basically failover of primaries and of replicas. But at least in the serverless product, that's all hand managed by the service. And so worst case, it'll perhaps have to retry a request or two during that time period. It might not show up on this screen because I'm just printing the average, but if we were to look at the P100s or the P99s, then we might see a period of elevated tail latency during that process.
How many nodes does a serverless cluster like this have?
So it's a good question. The serverless architecture is a little bit different than our traditional node-based architecture. So it has a different architecture. So the actual number of nodes behind the scenes is currently the same number that's supported in our provision, which is 500 individual single tenant data nodes
that's an up to, not my baby server.
Yes,
with 500, right?
Yeah. You're right. Yes, up to with limits. It depends on the use case. So serverless, one of the advantages of serverless is it'll auto scale based on the traffic. So not only do you pay just for the usage in terms of requests as well as the storage, but it will scale based off of how much you store or how much you're demanding from the system in terms of requests. This is, both a tiny workload, both in terms of requests per second as well as the storage size. So it's probably only served by a handful of nodes. All of the serverless products are replicated 3 ways. So out of the box, you get 3AZ replication. Okay. So 3 would be the minimum number here.
So when to do a live upgrade, you're saying you add a node. So it starts with maybe 3 because it's a small one. You go to a 4th. So like you add a new Valkey engine. So you've got 3 Redis, 1 Valkey. And then you take off a Redis one.
Yep.
And then you add because then you go to 3. Then you add another Valkey, you take off a Redis, add a Valkey, take off a Redis, and now you're good. And the cluster is compatible with Redis, and Valkey can understand the communication that they have with each other. So I never go lower than what I was allocated at 3 because I go forward, back to 3, forward, back to 3, forward, back to 3, done. And I've not seen the latency jump here. Are we done? Can we check it?
No, let's go back and check and see. Refresh. It still shows up as modifying. So that the entire process, we purposely do it slow because we don't want to, take down, as we said, everything all at once. So it doesn't look like it's done quite yet.
Okay. I have more questions, so that's good. We have more time. My next question. So that's how you do it with serverless. What happens if I'm doing it with the node-oriented version of ElastiCache?
Yeah, so it follows the same general process. So for both of them, it's sort of staged the same way that an engine upgrade would be. So in ElastiCache, serverless, and node-based, you can change. You go to the next version. This is implemented the same way as like a next version hop, and it does this N+1 also behind the scenes for the node-based.
I don't have to do anything to make that N+1 happen. It just I go to the node-based. I say please upgrade to, I guess in this case, 7.1 to 7.2.
Yeah, so if, we didn't show up on the screen here, but the latest version of ElastiCache for Redis OSS is 7.1, and the version that we launched just Tuesday for Valkey, ElastiCache for Valkey is 7.2. So there's because the Valkey 7.2 is based off of Redis 7.2. Which is a minor version bump. So it's API compatible. It adds a couple new minor features on top of 7.1, but is effectively a version upgrade from across the 2 engines as well.
So it's the same push button thing where I say please go from this version to this version, and without interruption, even node oriented. Is that what you call it? Node oriented? Even node oriented, it puts me to the new version. Now, usually serverless will upgrade from 7.0 to 7.1 seamlessly and invisibly without my involvement, right?
Yes. Yeah. So normally if you were to upgrade, just across minor versions, it would... so is the question on serverless?
Well, on serverless, you usually do a minor upgrade without user involvement. But this one time, it's a minor upgrade from 7.1 to 7.2, but still asks the user because you're switching from Redis to Valkey, right?
Yeah, that's a good point. So with serverless that launched late last year, we have minor version upgrades that are seamlessly flow out to all of the customers that are running on it. So if we were to have an engine with 7.1, 7.2, 7.3, 7.4, it would take you through those stages, and you just get the new features because it's completely backwards compatible, but you don't have to take advantage of them if you don't want to. With this change from Redis OSS to Valkey, you do have to opt into it. So even though it's API compatible, should be delivered, we want customers to make the choice that they are sort of switching to the Valkey engine, which will have a different feature set from Redis going forward.
Got it. Yeah, it's about the 5-year plan. It's about what I want to take the improvements that are going to come in Valkey. We'll talk about those a little bit later of what's coming. Because the great part is it's open source, so you can dish all the feature stuff.
Yeah.
Did it upgrade yet?
I'm interested. Well, I did see the latency drop precipitously.
Oh, you did?
I'm wondering. Yeah, I think it's unrelated, but I think, so the test Redis serverless did complete now. So it's available and it's under our Valkey set of caches here in the console. So I think it just happened to drop.
Oh my
I wouldn't
gosh!
expect.
When you said drop, I thought it was worse, but you made it got
Sorry,
better.
drop as in latency. Latency is 600 to 700 microseconds, and this, like I said, it's so variable based on placement. So just even where in the data center the given nodes are can make a big difference in terms of that latency that you see. So it just happens that we're probably closer in terms of the network path between the client and the new nodes that we provision running Valkey.
That is that is an unexpected. You're saving 250 seconds, but you're like, don't, no problem.
Yeah, don't. Yeah, it could have also done the other way of going up by slight amount too. But yeah.
When you said dropped, I thought it was in the bad way, not in the good way. That's really cool. All right, so let's talk about the motivation to do this, because by pushing that button there, when you went from Redis to Valkey and said go, you're saving a non-trivial amount of money. Can you talk about the savings that people get for doing this?
Yeah, and I have a little slide to help illustrate that. You want me to bring that up?
Yeah, please.
Okay, so yeah, we talked about savings. We didn't go through the exact one, and it differs for each of the different products. So we can talk through that. But basically, across all of the different SKUs, there is some there's lower pricing for ElastiCache or for the Valkey offering. So on the serverless one, which we just talked through and demonstrated, there are two pricing dimensions. It's pay per use, and so there's pay for the compute that you run in terms of requests, as well as the storage of your data in the cache. And so those are the two dimensions are eCPU for ElastiCache processing unit, and then gigabyte hours of storage. And for both those dimensions,
33%.
Both drop by 33% relative to other engines. And then additionally, for smaller use cases, we've dropped the minimum size of the cache. So previously it was for the other engines, it is currently 1 gigabyte, but for ElastiCache serverless for Valkey, we've dropped the minimum in terms of gigabyte hours to 100 megabytes, which is a 90% reduction. So you can get started now with ElastiCache serverless for Valkey for just $6 a month for the cache, and that covers all data up to 100 megabytes, and then beyond that, you would pay additional based off of the 33% reduced pricing.
So by hitting that button that we just saw you do, your cost for eCPU and gigabyte hours went down 33%. And this is probably a small cache. Does that mean that did that minimum impact this application? Like, does it go down to like 100 megs as well?
Yeah, so it would because the data stored in just that one simple leaderboard is far less than 100 megs, and so we'd probably be see more close to a 90% reduction in terms of that size, because we would be at the minimum.
So it went down 90% in minimum, because it's a small example, so good for like a dev environment where you're playing.
Yeah,
and then on top of that, it went down a third for the things that are being charged there. So you were living at a minimum at a certain price. Now your minimum just dropped 90%, so your price went down 90%. Plus, then it went 33% more than that.
Yep. And we did this because we wanted to, for a number of reasons. One is we've gotten great reception from ElastiCache serverless since we launched it at reInvent last year. We've seen a lot of people using it to get started and want basically to have a reduced minimum so they can use it for things like dev test environments. So we've put a lot of work into the overall infrastructure to try to improve efficiency and get those economies of scale. And we chose to release some of this as a cost savings through this new engine, which we see as the future of ElastiCache innovation. We see it as a way for us to continue innovating on the in-memory space more rapidly than we were able to before, and wanted to be able to encourage customers to leverage this future innovation.
So some of your hard work is going into the people who are watching this, saving some money, because you helped build this. That's got to feel
Yes.
That's got to feel pretty good, I thought. On the node-based, it's 20% on the node usage. So the SKU for that is down by 20% if you were
Yeah, so across, so the node base has, you can choose which instance types you want to use and the number of them, the topology. It gives you more fine-grained configuration on the node-based one. And all of the node-based pricing is reduced by 20%. It allows you to leverage your existing reserved instances. So if you made a commitment to Redis OSS, you can apply that commitment and get some added value by using it for ElastiCache for Valkey. And we support the Valkey engine in our free tier as well. So if you're getting started with AWS for the first time, you can use that to try this out for no cost.
And if I hit that button, is there a downside should I be aware of? What?
Is there any loophole? Is there any catch? No.
Yeah.
No. So
this is pretty good. What's the other shoe to drop? You just went. You did the upgrade. Should I be aware of something?
No. Your application will continue. It will continue working as is. There's no real downsides to pressing the button.
Right. And if you're on 6x though, then you got to think through because you'd be doing a major upgrade, right? From 6x to 7x is a big upgrade.
Yeah, so historically, Redis OSS has not made large breaking changes across major versions, although technically it follows semantic versioning, so a major version bump can introduce backwards incompatible changes. So if you're going from 6 or 5 or something previous to that, you can still jump directly to Valkey. That's supported within ElastiCache and MemoryDB. Both of them from any version to any version, but you'd want to qualify the application to make sure that you're not using any of the maybe peripheral changes. So looking in through our documentation, the versioning pages, you can see what exactly are some of the backwards incompatible changes, and those are largely around bugs that are fixed that might change the response to or added options. But in terms of the large scope of changes, we are able to jump from one to the other without any impact.
All right. What about MemoryDB pricing?
Yeah. So let's move to the next slide here. So MemoryDB for Valkey pricing, we talked about 20% in ElastiCache node base. For MemoryDB, it's 30% reduced pricing for Valkey node usage. But for MemoryDB, there's also another dimension to the pricing structure here, which is in terms of data written. So for every byte of data you're written, you have a price that you pay in terms of gigabytes. And so that is reduced by 80%. But in addition to that, we've also raised this free tier significantly. So it used to be 20 gigs. Now it's up to 10 terabytes per month that you're able to write to your clusters in MemoryDB for free, which covers a large majority of our customers. So by upgrading to Valkey, you may eliminate your data written costs entirely if it's below this 10 terabytes in aggregate.
Sounds like a lot. Is that a lot?
It is. It's a lot of data written. Yeah. And so we did this purposefully because we wanted the data written to be less of a concern for customers. And we've also, again, done innovation over the past year on the backend storage system for MemoryDB, this multi-AZ transactional log that underlies the durability and consistency layer for MemoryDB. And so are able to pass on some of those efficiency savings to customers through this new Valkey engine option.
Yeah. And once again, with MemoryDB, no second shoe to drop. If we upgrade from Redis OSS to Valkey, it's immediately 30% reduced pricing on the nodes, and
Correct.
The data written can go to zero for a long time for 10 terabytes of written data.
Yeah, and that's per month. So if you're using less than that, which many customers are, then your data written cost might disappear entirely.
That's great. People are asking, but I don't want to answer it yet. I just want to acknowledge that people are asking. They want to know what's coming in Valkey.
Yeah.
Next. And let's end the show by talking about the future. But I do think if let's say that I did this and you just convinced me, I will save money without a downside. What do I need to think about for my client calls? Like I use Python, I got a Redis or a Redis client or a Redis cluster client. So do I still do that? Because Valkey seems like a different thing. Valkey will have different features in the future. We're going to talk about them in a minute, but it's going to have different features. So I need a client that is going to work with those future features. Right now, there's no real divergence. But what do I think? What do I do? What do I pick for my client?
Yeah, so that's a good question. So I talked or showed earlier the example of upgrading in place, and that's still using a Redis client. So you can upgrade your existing application now and continue using your same client because the API is fully compatible. So everything that worked for Redis OSS continues to work within Valkey. But like you said, over time, the Valkey might have different features from Redis. And so we want to be able to have customers leverage that. And that's why there's a couple different options that you have into the future. Is that one is that you can use the drop-in replacement for the Redis clients. The Valkey project itself has forked a number of the Redis clients that were used for Redis OSS. And so you can switch to just the Valkey version of those clients, and it'll continue to be compatible with your existing offering. But just recently, we launched another offering for a Valkey client, which is called Glide for Valkey. Glide is the general language independent driver for enterprise. It's a big name, but Glide it sounds cool too. It's like you're gliding into your Valkey servers. Yeah, so
like Valkyrie is gliding. Okay.
So Glide for Valkey is a new client that is AWS sponsored under the Valkey project. It's open source, and we built this client primarily because we wanted to pass on some of the best practices and operational learnings that we had in running Redis OSS and now Valkey for over a dozen years across a large variety of different customers and use cases. And we saw that the existing client ecosystem was pretty fragmented and had some challenges in terms of handling of edge cases. The Redis cluster protocol itself is a little bit complex, and how do you discover when a node's gone away and a failover has happened? And so we saw some sharp edges on existing client where you needed the best configuration. So we tuned this specific client for those cases so that it will give you the sort of a robust handling of any errors that can happen in the cluster over time. And so that is available as an open source project for you to use as a new client if you want to adopt it for now. And it supports Java, Python, and Node.js currently, with a Go client coming soon.
So in Redis, there's a open source ecosystem that established over the years for this language, this language, this language. But you kind of get the quality of that open source project that each of one was independent. So with Glide, I understand you have a core that's written in Rust.
Yeah, so that's one of the innovations in Glide, is that because we wanted to provide the same seamless experience across different languages, we decided to put a lot of that complex logic in one place, in one language that can be leveraged then across all of the different client implementations. So the core is written in Rust, and then we have language bindings on top of that for each individual language, so that theoretically you could add more languages over time and have the same experience across them.
Someone asked, we had it on the screen a second ago, how do you think about features going forward between Valkey and Redis OSS, or is there any more future? Redis OSS is terminal, isn't it? So how do we think about that?
Yeah, it's a good question. So based on the license change back in March, Redis OSS was sort of end of life. There's no more open source Redis. There is Redis as an engine. It still exists and under the new license form. And so that will diverge. The existing clients, as they get updated, will conform to the Redis APIs. And so Valkey isn't necessarily going to have all of the functionality that Redis going forward will have. So the two basically will kind of diverge, which is why thinking of it as a fork is appropriate.
Right. There's not a mandatory, they must remain API compatible. They are probably over years going to have some feature divergence. Someone adds this, different engineering organizations will be proceeding, one open source and one closed source, right?
Correct. Yep.
Okay. Can we see the demo and see how you changed from the Redis client as a...
Yeah, let's pull that up on screen. So it's still running, still seeing decent.
It's still running.
Yeah, I'll stop it.
Still fast.
It'll clear out the state. But I'll just show you how you can switch because I had this pre-staged. So right now I'm just using this Redis client, Redis cluster. I'll comment these imports out. I've already installed the Valkey PY replacement client. And with Python, it's pretty simple to do this. I don't actually have to change any code. I can just import Valkey and call it Redis, and import Valkey cluster and call it Redis cluster. Or you don't have to do this. You could go and do a find replace in the code too. But if I were to do that and hit run, it's now onto the Valkey Pi client. It clears the stats. Sorry, whoever was winning before, but we're we're back to square one. But you can see that it's running with the same latency, same speed, and same functionality because it's just pulling in now the new lineage for the Valkey client. So you can safely upgrade it without and use all of the APIs that it exposes.
That's a cool trick. But I think you'd recommend this, I'm guessing, if you do the switch. You should probably, it doesn't matter today, because today the Redis cluster client speaks just fine to Valkey. But years from now, when there's divergence, that client will speak whatever Redis not OSS is doing. Correct. And the Valkey one will speak whatever Valkey is doing. And so if you want to use the new Valkey features, you'll need to do something like this, start using Valkey cluster. Or you'll want to switch to Glide, and so you have this option. If you're in one of the Glide supported ones, then you can pick it. Probably should test. Hey, do you like this API? Do you like that API? It's
right.
Both of them are different clients, and the hope is that I think the nice part about Glide being written on one core is that any improvement there on like node discovery is just available to everybody, and there's less divergence across languages.
Yep,
that's always kind of nice when you can do that. All right, let's talk about what's coming. People want that.
Yeah.
On that. What is coming in Valkey?
So that's what's exciting is that AWS, as well as a number of other corporate sponsors and individual contributors are making Valkey project prolific and trying to improve upon its functionality over time. So 7.2, which is what we launched on Tuesday for the services, is just the beginning. It's a drop-in replacement. It doesn't add a whole lot in terms of new capabilities, but the open source project is continuing to innovate. And so 8.0 is the launch that just happened last month for Valkey open source, and it included a number of different more exciting contributions. Some of which came from AWS. So we have drastically improved performance that went into 8.0 in terms of how many requests per second you can get from a single node. And so there's, I forget the percentage, 70-something% increase in terms of max DPS, up to 1.2 million requests per second per node based on our benchmarking from the open source client in 8.0. And so that will be coming in ElastiCache and MemoryDB in the future. So you'll see some benefits there. Going forward is interesting too, because that was just a point release after 6 months of the project operating. But of course, we're looking at the long-term roadmap. What do we see Valkey doing in 3 to 5 years, and where will it go? And so there's a number of different ideas, and this is where you at home can get involved and help steer the project, because that's the benefit of being an open source, is that you can suggest ideas and or contribute to realizing them.
So what's coming, man?
Yeah. Okay. This was so the first thing, the top requests on the list are new capabilities. As we talked about, Valkey and Redis OSS are well known for their data structure. So there's been a lot of interest in adding new data structures. So things like Bloom filters is something that we're working to contribute upstream to open source as a new data structure. VSS is an interesting, so vector search rather, capabilities, which, like we talked about earlier, we have in MemoryDB, but isn't part of the open source ecosystem yet. And so that's an interest in getting it upstream. Same
And
thing
everyone can
for
use it. It's an ElastiCache because
Yep.
right now it's only in MemoryDB.
Yeah,
So
we can use it.
it's
It's
a
in
non-open
different
source.
providers. So this would be part of the core open source project. JSON capability too is something that they've you're pointing at yourself. So that is available
JSON?
in ElastiCache and MemoryDB now, but isn't available in the open source Valkey project. So there's interest in adding those. And then other functionality that is of interest to the community. We've heard some requests for things like hash field expirations, of being able to more finely tune when things get expired from collections. That's on the roadmap of interest for the next version of Valkey. And then beyond that, it's, I think, up to what who's able to contribute and what the requests are for that.
Vanguard says, any interest in making Valkey data structures multi-threaded like memcached does? Boy, Vanguard Space knows about their caches.
Yeah, it's a good question. So with this 8.0 release, the data structures themselves are not multi-threaded, but the actual backend connection processing is, and that's how it's able to achieve much higher throughput overall. It's a good question as to whether we want to make the data structures themselves multi-threaded and thread safe. There's the complexity trade-off of, okay, now we have to manage locking and concurrency on those data structures. But I think for some data structures, it may make sense. So it's worth proposing that. I think the goal with Valkey is that it's trying to be a little bit more aggressive in terms of the innovation relative to Redis OSS, which is a little bit more conservative in terms of its technological advancement. And so more innovative ideas are definitely welcome to be proposed within the community.
Yeah, cool. So I think the key takeaway is now we understand what ElastiCache and MemoryDB are. So if you're not using it, consider if you might want to use either of those. But if you are, then definitely upgrade to Valkey and get a cost savings. No matter how you've deployed, there's a significant cost savings to be had. Without that, there's no backward compatibility issue.
Right.
But do upgrade your clients. It doesn't matter today, but you want to upgrade your clients to be on the Valkey version of clients instead of the Redis version of clients for what, like Python we showed, but any other language.
Yeah.
And consider going to Glide, or try the Glide version out if it's in one of the languages that you use, because Glide is probably over time going to really, I'm guessing, be great for enterprise workloads, because you focused on the enterprise hardest hitting edge case handling workloads there, right?
Yes.
That's the key takeaway. All right. Fantastic. Thank you, Kevin. There was not a single question that stumped you. I tried. The people tried. It worked well.
Thank you for having me
here. Hope to see you back when these support the 8.0 version.
Yeah.
We'll talk about 70% performance improvement.
Yeah.
It's pretty wild. So with that, we'll end it. Thanks so much, Kevin. And next week, we're going to do innovation in Aurora Global Database. That'll be the topic next week. I think I've done 4 shows in a row at this point, 4 weeks in a row. Next week, I'm taking off back to the Aurora side and Aurora Global Databases. So join us next week, same time. Thanks, everybody.
Thanks.
Thank you, Kevin.